Well, hi, good morning, and thank you so much for joining me in my shop here. Today is September 22nd. It's been a few days since I posted a video, but I wasn't here yesterday trying to sort out a simple matter, which is how to connect my shop speakers to this receiver here. Well, I spent a couple hours on that simple problem. I did not bother posting a video because at the end of those couple hours, that's pretty much exactly the same place I was when I started. Still unsure about where to connect my speakers. Now, normally this is a real simple matter. Take just a minute or two to sort out, maybe 5 in some cases, to sort out how to connect your speakers to it. A receiver like this, the reason this is a bit of a high anxiety operation is this is the speaker connector, and here's the wires at the back of it. And not only is there a speaker signal sent here, but 120 volts from the power cord is also sent to the same connector. And the only reason I can think that they are doing this, I'll show it to you on the schematic, is because they've made an allowance to plug in powered external speakers. So perhaps you could buy 2 external speakers for this radio that have some kind of amplifier inside them, and it requires power, and so they've brought 120 volts up to this plug. So when you plug in your speakers, you're supplying them with power. Well, I don't want to supply my speakers with any power. That's for sure. I just got ordinary speakers here. Nothing too special. Loudspeaker approximately 5 ohms. Hi-fi panorama speaker or stereo box. Hi-fi panorama speaker. So I'm guessing the hi-fi panorama speaker in a box is powered, has an amplifier in it, and is made specifically for this receiver and maybe a couple other very similar models. And you could buy those speakers when you bought the receiver if you wanted to. So the problem for me is which one of these terminals has 120 volts on it, and you might think that's a simple thing. Much of my time yesterday was spent discovering the fact that there's 120 volts on there, not by measuring it or anything like that, just by studying the schematic and realizing what I'm looking at, which took a long time. So consequently, my concern here is I'm going to make a mistake. I'm going to hook my little speakers up and blow them to smithereens when I plug the unit in. Let's look at the schematic just to prove I'm not crazy, and hopefully that's what it proves, and then we'll try to sort it out this time. Okay, so here's the schematic, and you can see the 2 output tubes here and 2 output transformers here. We have the primary side of each of these transformers, and we have the secondary side with 3 wires. You might remember me a video or 2 ago going, 3 wires, 3 wires. Why are there 3 wires? Well, there's 3 wires because one of them is designed for a 3 ohm system and the other one is designed or intended for a 5 ohm system. Now, most common speakers are 8 ohms anyway. That's kind of odd in itself. And one wire is a ground lead. You can see the ground lead coming here. So we have 2 different impedance possibilities, if you like. And the output from here is sent over to this jack or terminal. Now look at these 2 wires here that say N. 3 and 4. We can find the matching N over here. There it is. And look where it's connected. It's connected just after the switch, not even on the other side of the fuse. You would think that at least they would hook it up here, so you would have the benefit of the fuse in the circuit. So it's an unfused power. Just a little surprising to me that they would do that. And it comes onto the back of this. Now, there's numbers here, but there's no numbers in the actual chassis. Down here is the plug that goes into it. This has no numbers on the diagram, but it has numbers on the actual plug. They're actually in the plastic of the plug. This is the kind of stuff that I've been stumbling around through for half an hour trying to figure out what exactly they're showing here. Especially this part here, which is in German. Let's make it a little bigger. It's in German, of course. I have to kind of guess at what it's saying. 110 to 220 volt Belucci Fung Laufwerk. So I have no idea what that means, but I'm guessing power for an external speaker. That's the only thing I can come up with about this. So it looks like a pretty simple matter. You know, these aren't random. They're shown the way they are. They're shown the way they are. It should be pretty easy to spot these two and then just work your way back. This is what I gave up on doing at the end of yesterday's session. I just gave up on it. Maybe I've been in here too long. It took me quite a while to realize this situation existed. So what I'm going to do now is I'm going to stop, drink some coffee right away, and then we're going to try to figure out how I can safely hook up my speakers and not be, you know, concerned I've hooked that up to one of the power lines. One of the challenges I faced yesterday was I could never find the high voltage in the radio. Now, I never plugged the radio in, but what I did is I just looking at the schematic, these wires from the plug should go straight to this 120 volt terminal arrangement here somewhere. But do you think I could find that connection by using continuity checking? No. It's as if it doesn't exist. So, you know, one thing I could do is I could plug in the set, have no speakers on it, and poke around looking for the high voltage. I could. I'm a little anxious about plugging this in just yet. So yeah, that's the situation. Let's look at that schematic again. I just want to look down here. So it's just past the switch. That's good. Past the switch. So the thing is, if I close the switch or turn the set on, I should be able to find continuity from here to here, or to the other wire. I'm going to repeat that test. Maybe I did something dumb. I don't know. Let's just repeat it here. This should certainly work. I can't imagine why it wouldn't. Now, you can see I still have some connections from doing this exact test yesterday. Okay. There. Now I'm going to use a clip lead on the wires. I'm going to clip to both wires to make it even easier. Now I'm going to check by touching the wires. Oh, I missed one here. Let's go this way. Touching the wires. Oh, yeah, there it goes. Okay, so I made contact with both wires at this clip lead, and the clip lead is good. You wouldn't see it on the meter. Now, one of these contacts on the back of this connector should cause this to drop to zero. This is a ground connection here, quite sure of that. And just go around. Go around as best I can here. There's nothing even soldered to this connection here. There's nothing soldered to this one either. And then we're over here. So, you know, pictorially, this matches. So this is the one here that I expect something to happen with. Oh. This is empty. So you see none of them, and the set is switched on. You switch up here is on FM. Come on. Sorry about that. I'm sure that was hard on your ears. So I can see this bundle of wires coming down here. These are the leads coming from the output transformer. You know what? And it just, there's other elements in here I'm not going to go into. There's connections that I don't understand. They don't appear on the schematic, like this wire here, heading off down into here somewhere. What's that doing? So the thing about the schematic is I'm looking at a schematic for model number 151. This model in front of you is 152. I think they're the same model, one destined to the United States and one destined for here. So there's some slight variation, usually around the power cord, 3-prong, 2-prong, all that kind of stuff. Could be a little different between the United States and Canada. So this arrangement, which appears on what I believe to be the American schematic, maybe doesn't exist in the Canadian version. Maybe they didn't allow it. So you can't do that. You can't bring that power up to something like this. Maybe it doesn't exist. Maybe. I mean, every test has suggested there's nothing going on, and I think I can see the speaker wires. The next step is to experiment with speakers, I think. I suppose I could put my scope on. I could put an instrument like a voltmeter or a scope. I don't have to worry too much. If I hit 120 volts on a voltmeter or the scope, that won't matter. Then maybe I can detect where the audio is just by looking at the scope display. That's pretty tricky when you're dealing with, you know, a big unknown here in the first place. I gotta think a bit more about that. Yeah, next step is going to be actually experimenting with a speaker, I think. Well, not so common, but they've screwed the cord right in here. And I have an alternate cord with a plug on the end, which I'm going to use. Hopefully fits. Let's take a look. Hey, what did I do? What did I do with the cord I just had in my hand? Here it is, right here. It's right here on the bench. Right here. Looks pretty good. Yeah, fits right in there. Excellent. So now I have a regular plug on the end. So I'll be plugging this into this guy here. This is really just an ordinary outlet. It's not even a 3-prong outlet. It's a 2-prong outlet. So you can see the ground prong is protruding out. Just so you know what's going on here. These are really handy devices. You can run around and see how much power your vacuum's using and things like that. Great in the shop here. So I'm going to plug into this. Again, even though this is polarized, there is no polarization in here at all. In fact, this gets its power from a transformer, an isolation transformer. So there's no direct connection back to the power system. It's isolated by a transformer. Not this. This also is an isolation transformer with a variable control on it. And yeah, for some reason I still have not been able to explain to myself. I have both transformers going. So double isolation doesn't make a lot of sense, but that's what I did. Now, in order to prevent a disaster from happening, should I plug in a piece of equipment with a short circuit in it, I also have another sort of power thing going on here with these two light bulbs that you can see back here. So what I can do by choice is I can send the power to this outlet and therefore to the project through those light bulbs, or I can bypass the light bulbs. If I bypass them, then it's just like having something plugged into an outlet, except there is a isolation transformer still involved. On the other hand, if I pass the power through the lights on the way to the work, there's a short circuit in here, all that happens is the lights come on full blast. And it's pretty obvious here in the shop, so it's a great thing. It's like a warning system almost. Something's going wrong. Also, with the lights in the circuit, the amount of voltage that reaches the project is reduced. Sometimes quite reduced, cut in half sometimes. So it depends how much current this thing is looking for. If it's this is a fairly big radio, fair number of tubes in it. So probably with both these light bulbs in the circuit, these are in parallel, like any lights would normally be. They're in parallel, then they'd be in series with the work. You'd probably end up with about 75 volts on this, with the two lights glowing a little bit. That would be normal. And that would be a good way to start here. Because when I hook up the speakers, if I make a boo-boo, now I'm not going to hook up the speakers immediately. I am going to do the use the oscilloscope here to poke around a bit as best I can. And I think all I got to do, a little practice session here, is all I got to do is touch that for this, and I will see an output from the receiver. Now the second, whoops, can't see what I'm doing. The second challenge here is, this is what I was doing. I was just touching these terminals here, kind of practicing before the power's on. And then the other terminals, can I move this out of here? The other terminals are a little difficult to get at here. One's here, and the other one is this one with the resistor on it. I couldn't find these resistors on the schematic either, which is another thing making me a little nervous about this. These are pretty close together in here. Okay, let's turn on the oscilloscope here. We're gonna just have it sweep at a nice rate. Put this on DC. Put it up to 0.5 volt, put it a little higher just in case I hit the 120 volts, which I don't think exists down here. Now, so I'd be operating the set with no speakers attached, so probably better to have the volume turned right down. I have to turn the volume up to see it. And what am I turning the volume up of? Goodness knows. So I'm going to switch to AM radio here, broadcast band, because at least there's going to be some noise. On the FM band, I'm not too sure what we would have. I suppose with most radios you tune between stations, there's quite a loud hiss, and that would be enough to see on the scope. But we'll start with the AM radio because it has an antenna connected. It has a, make sure it's switched on, a ferrite antenna, which I will switch on according to that. Okay, now, just thinking hard about this. Volume is down. And these buttons are pushed. I'm going to grab this. You know what? I can stick it right on here to start right now. And I'm going to set it. I'm going to set a camera up to see the scope. Okay, I think we're ready to start here. Let me just back this up a little bit. Now let me just check my oscilloscope. I'm getting nothing here. How come? Because I don't have it very sensitive. Yeah, everything's working fine. Make this a little bit insensitive. So when I start it up, I'll be starting it up through the light bulbs. There's not much reason for doing that really, because this was operated in its cabinet. It's been used with a fair bit of regularity, so it's not like this hasn't been operated in 20 years. There's nothing like that going on. So, oh, what's this? This is a wire kind of sticking out the back, but it's been cut. Just it'd be like a ground wire of some sort. It's been cut. Okay. Well, anyway, just put it on the list. If I'm operating this at a lower voltage, like 75 or 80 volts, there's a chance the tubes will not operate at that voltage. So you won't get any output, so I won't see anything on the scope. So I'll be poking around here and never find anything. So we really have to operate this pretty close to or at its regular supply voltage. The voltage that we're running it at is reported on this guy here. And you'll see this meter back here pop up too, but don't pay too much attention to it. And you can see I'm anxious about doing this. I'm not so happy about it. Okay, so volume is down again. I think everything's okay. There we go. Okay, so it's on. As soon as I hit the power switch over here, you'll hear the click of the power switch. You'll see this thing start coming on. If I hold it this way, you can more or less see it. And but we have no speakers, right? You're not going to hear anything. Here we go. Watching the scope, and you see the lights come on quite bright. This thing's drawing a fair bit of power at first because the tube heaters are cold. And because they're cold, the resistance is low and there's a rush of current into them. I see panel lights are on. They look pretty normal. Voltage is 95. Most sets would work at 95. So now we really want to watch the scope. Scope hasn't done anything to make it much more sensitive. That's maximum sensitivity. I'm going to turn up the volume. Bingo. Here we are. So you can see some noise in the image there. So this is definitely a speaker connection. Thumbs up. Okay, and no funny voltage. I've got the scope set on DC. So if there was any voltages here, AC or DC, we would see them. Now I'm going to go over to this other one here and see if we don't see kind of the same thing. Okay, I'll turn it up. Same thing. Okay, so I'm reassured. I'm going to hook up my speakers to that spot there. I'm going to turn off the power. Take this out. Maybe I'll be cautious enough. I'll only hook up one speaker. I guess we don't need to be looking at the scope anymore. Let me get this hooked up here, because I'm going to go sneak some coffee in too. Okay, ready to repeat, this time with speakers connected. You can see the wires here clipped in, and the speakers I'm talking about are just little guys way up high here. Just one of them here, and the other one is his brother way up there. That's what I'm talking about. So, I mean, if I did blow those up, it wouldn't be the end of the world, except I would be embarrassed, disappointed. I don't think that's going to happen, though. That's been one of the weirdest odysseys that I've done in my shop here. I did not post the 2 hours of me running around in circles trying to sort this relatively simple thing out. Boy, I tell you. Let's give it a try. Let's see what it's going to do. So, volume's down. We're going to fire it up. Still using the light bulb. I didn't say this. These light bulbs are called the dim bulb system, although it's not much of a system. But if you want to read more about it, I'm sure there's stuff written on the internet. It's a very simple idea, and I find it very effective. As you can see, I have the alternative sitting right here. This great device here, it's got a big knob on it. I can change the output voltage up and down, all I like. Yet I like the dim bulbs, because if something goes wrong, 150 watts of light in your face. So Okay, this has got to be warmed up now. We're at 80 volts, we're a little low, but let's turn it up. Well, I hear it. Now, is it both channels? Yes. So the balance control, I noticed this when this was still in the cabinet. The balance control is not 100%. It doesn't move the sound 100% this way or that way. It's like a 50%, so it just kind of moves it a little bit. And in fact, when I have it set in the middle, with these speakers, sounds a little loud on the left. It sounds better balanced when I have all the sound directed that way. So there's something a little off with the balance here, and that could indicate variations in the strength of the output tubes or anything. I think it has two different output tubes in here. It has a replaced 6BQ5 and then the original EL84. So maybe the original one is weak now. Could indicate all kinds of other things. These old capacitors could not be doing the job the same from channel to channel, and you're getting differences. But that's full volume also. Is that because of how I hooked this up? I don't know. Full volume? Wow, that's really sad. So I don't know what the situation is with that. I can't judge it really. We'd have to put it all back in the cabinet again. I don't remember it being weak. I remember it sounding really good on FM. That's what I remember. So it could just be mismatch in the impedance of the speakers and the output and all this kind of stuff. Let's see if we can tune in a station here. I think we'd want to be at the lower end of the frequency. It's absolutely no response at all. So I remember right now, when I tested this, it was out, not in my shop, it was out in my garage in fact, and I was able to pick up a couple of AM stations kind of weak, but they were there. I have some ways of boosting it here. Let's boost it. I'm going to have to stop the video for a minute. I have to go do a little antenna switching here. Okay, so I have an outdoor antenna called a mini whip antenna, and you can type that into Google and look at what a mini whip antenna is. It's only about this big, and I've actually abandoned my wire antennas in favor of this mini whip antenna, which is a better performer than any wire antenna I've ever had on receive. So I'm going to hook up this into this loop. Let me back up. So the feed from the outdoor antenna is here, and I'm going to hook it up to this loop. The outdoor antenna has an amplifier in it. It has a fairly strong signal coming down. So now that signal's in this loop. I'm going to put the loop near the antenna of the radio here. You can hear a difference already. Just making sure it's not shorting anything out. Now let's tune. See? Fantastic. Okay, well that would rank as disappointing. There's a switch up here on the radio. That should switch off the ferrite antenna. Really? Didn't make any difference. Ooh, what was that? That was probably something being turned on and changing the hum levels in my house. Something turning on somewhere. I don't know what that would even be. Well, it's not receiving anything at all. Another possibility is I'm only running the set at 79 volts, which is way low. Which is actually, if it were 100, I would be pretty sure it would operate. But at 80 volts, there's a chance one of the tubes is not operating in here. So we're going to push it up. I'm just going to push it up with this. Push it up to, it's only 90. Well, we'll try it. 90 make any difference? A lot more volume. So that's why the volume's low and the voltage is low. Okay. Anybody? Let me turn on this ferrite antenna switch again. doesn't want to pick anything up. And it could be also this push button may not have made proper contact. Part of the reason I have this out on my bench is to clean the push button. So let's give the push button a go here. And this is okay. So that's switching to the tape recorder or record player input. Back to sounds exactly the same. That's the volume gem, not the tuning. Hey, hey. Okay, we're getting a little bit. That's not English. Oh, for crying out loud, the scale here is backwards from what it wouldn't be normally in North America. So the low end is up here. This is where the stations will be. No, I've been looking down here. There's really not much. So if it's picking something up down here, let's go at the other end. We should get some strong stations up here. We should. Oh my. Should be a strong station right around 590, which would be here. That. Well, that's kind of interesting. The non-English station would probably be a local, low-power community station, probably in Toronto, which is 100 miles from here or so. So, interesting, it works at the high end. There's a good oldies music station up here. So what that indicates to me is the radio is out of alignment. It should be picking, if it's picking these stations up down here, it should be picking up the ones here really strongly, but it's not picking them up at all. Now that's probably an alignment thing. The alignment is worse at this end than it is at this end. That's my take on that. We can flip it to FM. There's no longer an FM antenna connected. Well, let's just try it. No antenna. What the heck can happen? Okay, that's FM. There's the FM hiss. And we're not going to get anything without some kind of antenna. Oh, careful, this cookie is moving. If we wanted to do that quickly, I could do it with my finger. Huh, didn't react at all. That's a little odd. I would expect some crackling or some variation there. Let me just quickly take a look at the who's who here. So you see the terminals on the chassis are duplicated on the back. And there's just some wires that go between. So this is FM this way. FM on that side. The smaller plug, the tighter plug. This is the tighter plug. So this is the FM here. Don't give up too quick here, Jim. Let's try just putting in a wire. Nothing at all. I'm sure I listened to this. Maybe again it's bad. Ooh, that was pretty bad. Sounds exactly the same again, so I'm not so sure the switches are a problem here. We're still at low voltage. Let's give it the whole shoot and match here. So I'm going to turn this down. I'm going to turn this guy down to where it should be, about here. And then I'm going to flip a switch. You'll see the dim lights go out. Now there's a full voltage here of, still low, 102. How come so low? 110. Okay, we're in the range. There's no excuse. No excuse for you now.
One of those boxes of documents that she had signed a confidentiality agreement that said that she wouldn't talk about him or give out the documents. That's his case. That's his side of that. And just with him, and then
Lovely.
He was suing myself and my colleagues in the Times, accusing me of torturous interference for basically he's arguing I forced her to give over the documents. And in that case, there's laws in New York.
Okay, I'm going to give you a lesson in FM. Why is FM so quiet and AM so noisy? Why is that the case? What magic is going on in FM radio that they can make it so quiet when it's tuned in to a stronger station? So when you're listening to AM, amplitude modulation, you're listening to variations in the strength of the signal. And when you're listening to FM, you're actually hearing variations in the actual frequency that's being sent. And these variations can be undone by the radio and turned into sound in your speakers. So on FM, there still is this noise, if you like, lightning crashes and everything that are coming through in amplitude modulation. But the frequency of the signal only changes when the station changes it because of the program material. So you can have all the noise you like, lightning going off, it has no effect on the frequency that's being sent. That kind of makes sense. But the amplitude, it's going to pick up all that noise. So you end up at the start of an FM radio with all that noise in the signal. And you have the FM, the frequency variation going on too, where the program material is. As it goes through the radio, it's processed and strengthened and all that, but the noise is still there. The noise is still there until it reaches a circuit called a limiter. It's one of the, just before you get out to the speaker, you go through something called a limiter. And what that does is all this stuff is chopped off because the limiter is only this big. And all the signal doesn't go through, just this middle part goes through. I'm kind of explaining this pictorially. And when it goes through on the other side, it's perfectly smooth like this. All the gibberish is gone. So all that amplitude modulation is gone. So all the noise is gone. And all you're left with is the frequency modulation that you're going to listen to. And that's why FM is so quiet. And now I'm going to demonstrate it. I'm going to tune the radio off frequency a little bit. When I do, the signal will decrease and decrease until finally it's actually smaller than the limiter. At this point it's going to sound very crappy. But what you'll notice, like the quality of the program material will become crappy. But you'll notice that AM-like noise will start showing up. There'll be crackling and clicking and all that stuff that you would normally associate with an AM radio. Simply because the signal now is below the limiter, and so it's carrying all that noise. It's going through the limiter, coming out the other side. It's still got all the noise in it. That's why you need to tune a strong station on FM to get full quieting. That's what they like to call it, I think. So let's experiment here.
How Donald Trump squandered his father's fortune and created the illusion of success.
Yes, he did. Fooled me for a while. Now, I'm going to tune right in the middle. Unfortunately, they're playing music. I'll get a copyright hit if I let the music go. We were listening to CBC Radio, by the way, Canadian Broadcasting Corporation Radio. It's not a commercial station. It's a government-funded communication system across Canada. Everybody in Canada can tune in to CBC and hear kind of the same thing. It's a little local. They have local announcers and stuff like that, local news and things. But anyway, that's what we're listening to. Usually they're talking. Good, they're talking again.
Or Levi, should I say?
Now I'm going to tune off, and as I do, and the signal comes down, gets below the limiter, you'll start hearing the noise. Hear it? Let me turn it up.
particular story at this particular time of event?
Limited?
The Wizard of Oz was a very big deal when I was growing up in my family.
Not limited.
I used to watch it all the time.
And then when you go between stations, of course, the signal now is like this. It's just passing through the limiter and coming out the other side exactly the same. And that's why you hear the amplitude modulation noise. Speakers don't run on FM. Speakers run on amplitude modulation. So at some point in this radio, right at the end, and all these radios, at the very end of the FM circuit process, the signal is changed to amplitude again. It has to, because it has to be amplitude modulated to operate a speaker. So I won't go into how they do that, but it's a little bit of a trick to it. Of course, the whole thing is one gigantic trick, isn't it? So there we are. So that's why if you tune in a weak FM station, it might be full of noise. It's not strong enough to enable the limiter action.
Preamble to it. It's actually part of the song, but it's often not sung, especially when people cover it and make their own, which goes at the beginning something like...
Another thing too is a modern FM radio, and modern would be, jeepers, late 70s, I guess. A technique was developed called a phase-locked loop tuning, and what that does is it kind of locks in on the FM signal, kind of hangs on to it. As you tune into it, it'll kind of grab it, and as you tune out, it'll kind of pop out. Something like that goes on. These older radios don't have that capability, so they don't kind of grab the FM signal, if you like, which makes tuning these guys more critical, and it makes drift a problem with these radios, again, with a weaker signal. And with AM, you can listen to a signal like a broadcast AM. You can listen to a signal as weak as you like. With FM, it kind of has to be strong enough to do the limiter thing, or you don't want to listen to it at all. Because, after all, we're looking for that FM experience.
I to why, oh, why can't you and I? And she's used...
So we're getting a little bit of time to operate, too, because I'm going to do a thermal study on it now. I'm going to find out if anything's getting hot in here. In particular, these two things at the bottom here. These two guys. See how they're bolted to the chassis? They're expected to get a little bit warm, and they're bolted onto the chassis. Here, I don't have to compete with her. Bolted onto the chassis to get the heat to go away. But as these things get older, these things can get hotter and eventually burn right up. So a lot of people would change these. In some radios, yeah, that makes a lot of sense. In these European radios, these things are quite reliable. That's my experience. But let's see how hot they're getting. I'm operating the radio at 113 volts, which is not out of the norm. Now we're going to bring up my viewer here, which already is picking up some pretty hot stuff down here. But let's start at the top. It's difficult to show this on camera, unfortunately. I'll try my... Oh, there's something quite hot right in there. How hot? So I can read the actual temperature if I put the item right under the center. I know you probably can't see it. There's a plus sign marking the center of the screen. Yeah, you can see it. Whatever that plus sign is on, this is the temperature of it. So we go to this hot thing, and we're looking at 52. So in terms of a radio operation, for many parts, that's not terribly hot. And there's a big whopping resistor right here, and that's almost certainly it. And there's something else going on behind it. There's a vacuum tube right back there. Heat from the vacuum tube will come down through the pins and heat the whole socket up, and eventually you just get a big red blob when you do this. And that's what that blob is. So that's the and there's no reason to think there's anything wrong there. And this is the resistor again. We'll measure the temperature of the resistor very carefully. Now this device I've got actually has two more temperatures, the green one and the red one. The red one is telling you the highest temperature on the screen, and the green one's telling you the lowest temperature on the screen. So I don't even have to get this plus thing set up. I could just hold it up there and look down here. 71. So something on the screen is 71 degrees. That's getting a little warm. Definitely getting a little warm. Okay. But not enough for me to panic about it. If it were 100, I would start really wondering. So what's this now? This is a little guy here. And it's very difficult sometimes to figure out what it is that's actually on the screen. So often what I do is I do blocking. I need a piece of paper. Here's a good one. Called Transit Control 555. So yeah, if you know anything about the Toronto Transit Commission transit system, that's the internal phone number to phone. Transit Control. I think with cell phones it doesn't matter anymore. Okay, so I was going to try to figure out what this was. No, I'm not. Let's go looking for something else. I'm really interested in those parts down at the bottom anyway. And we're going to scan through. Once in a while I have found a bad capacitor this way, which is really far-fetched in my mind. And again, I'm sorry if you can't really see what I'm doing. Just looking, there's a tube socket down there. Oh, lots of hot stuff down here. Holy smokes. So I'm going to make the thermal viewer less sensitive here. So we have to have a higher temperature to generate the red color. So we can really kind of zoom in on what it is exactly. Again, I'm sorry that you can't see this very well. So there's a number of discrete hot things in here. The maximum one is at 120 degrees. So there's something very hot down in here. Right where I was connecting up my speakers. Which one is it? So I'm putting the plus sign now on each red thing. There we are. There it is. So there's a bunch of resistors down in there. Now I'm not going to take any kind of action based on this. What I'm looking for is a dire situation. Don't operate this radio anymore. But there's nothing like that coming out. Usually dire situations come along with smoke smell. So I'm not smelling any of that. So this guy, this black resistor here, is running at about 110 degrees. Again, quite hot, but that's a wire wound resistor and it can take it. But really, do you want a 100 degree item in the bottom of your radio? It's heating everything else up. Okay, so we're going to look at these two guys here now. These are the rectifiers that are in the power supply. How hot are they? So there is no particular heat in them at all. There's nothing going on in them. If they're getting warm, it's because they've got a resistor right next to them that's heating up. Now to double check that, reality check, my finger very carefully. Okay, so that's warm. This one's a little hotter, but these are not seriously hot. That's very good. So just making sure the rest of it, I haven't missed something. With bad capacitors in here, there is a chance of a resistor running much hotter than it would if the resistor were not bad. But I don't, it's a little hard to determine that. Unless, once again, smoke comes out of the resistor, or the radio doesn't work and eventually you find a burned open resistor. You could probably continue looking and find a shorted capacitor. And the resistor's burned out because the capacitor is shorted out. Okay, I'm going to call it quits here for today. I'm in a position now to really do some work on this guy. First thing I think we would want to do is I don't know. I'm not going to try to decide that now. I mean, it could be component replacement. I got some ideas. I'm not going to go into it. Thanks a lot for watching, and tomorrow we'll start trying to sort out if there's any real technical problems with this radio, especially related to capacitors, and we'll start switching out some of these capacitors and testing them to see what condition they're in.
Particularly happy in
plasticity. I think that she had aspirations, and to a certain extent, they got pushed on to me. I became her surrogate for.
Okay, no clue what he's talking about. Enjoy your day. I'm gonna go enjoy mine. See ya.